Hi. On this channel I'm often not very complimentary about vibe coding, but does it have its place? In this video we're going to look at some of the trade-offs that we might make when we consider whether to vibe code something and the situations in which that's a useful approach to take. So make sure that you're hydrated, put yourself some background music on, let's get into it. The framework we're going to use to evaluate this decision is Ward Cunningham's idea of technical debt. Now, technical debt has changed in meaning over the years. A lot of people use it now to mean a decision that was made in the past that is causing problems to software developers today. For example, picking a library to use that has subsequently been updated and not keeping track of those updates in your own project. That's not actually what Ward Cunningham said. He was talking about the experiences of a company building a portfolio management solution, a system that provides accounting and record keeping and so on. He said some key implementation ideas were slow to emerge in the course of Ycash's development. They were using an incremental approach where they started with a working prototype and iteratively extended it to reflect their growing understanding and their growing capability to deliver the features that people wanted in this system. Although many of our objects are derived directly from things or concepts that appear in documentation, and others were easily drawn from the collective experience of programmers, a third category of objects only surfaced through a process we would call incremental design repair. We found these highly leveraged abstractions only because we were willing to reconsider architectural decisions in the light of recent experience. The same flexibility that allowed us to tackle diversity in our problem domain allowed us to include architectural revisions in a production program that would be judged too dangerous for inclusion under any other circumstance. I go on to say that shipping first-time code is like going into debt. A little debt speeds development, so long as it is paid back promptly with a rewrite. The danger occurs when the debt is not repaid. Every minute spent on not quite right code counts as interest on that debt, and entire engineering organizations can be brought to a standstill under the debt load of an unconsolidated implementation. So that's the framework, that's the idea of technical debt. Now, how does that apply to vibe coding? So what Ward Cunningham's definition of technical debt shows us is that technical debt is a situation where there is some cost to using our incomplete or early understanding of the problem that we're writing code for, but that can be paid off by the value of having the incomplete code or poorly understood code. If that's more rewarding than not having the code, if we choose to have some value up front that we know we're going to be paying for later and understand that to be better than waiting until we've got the full understanding and only having the code after that, it's worth getting into debt. The way to pay that debt off is incremental design repair. It's working on the code to bring it up to date with our improved and evolving understanding of the problem. Vibe coding opens up a new possibility. We can ship code not only when we don't fully understand the problem domain, but also when we don't understand fully how to implement the code. We don't understand either the design space or the problem space. Okay, so what we see then is that vibe coding gives us a new opportunity to go into debt on our code on a new dimension. The existing definition of technical debt refers to shipping code before we have a complete understanding of the problem that we are trying to solve and the solution that would be desirable by our stakeholders. With vibe coding, we also get to go into debt on not understanding the code that it is that we're creating, on being able to ship something before we know how to write it. Now, is having more opportunity to go into debt a good thing? Well, using that same calculus, it can be. It can be a good choice to go into debt if the reward is big enough and if the payment plan is affordable. Anthropic recently produced a preprint called How AI Impacts Skill Formation, where they showed that on average, people who used a coding agent to generate the solution to a programming problem understood less about the solution to the problem and about the code than people who didn't use AI to solve the same problem. So vibe coding clearly does represent going into debt. It represents going into debt by deploying code that we don't really understand. But it can still be a deliberate choice that's the best option for a software engineer to make. It can be worth going into that intellectual debt. We need to have the payment plan in place, and that payment plan is incremental design repair. In this case, not only the form of incremental design repair that Ward Cunningham proposed, where he said that as our understanding of the problem and the solution evolves, so we should keep our code evolving to track that understanding and to make sure that we use our latest knowledge and don't freeze our solution on our earlier imperfect understanding. So we should also apply incremental design repair to our coding and our understanding of how to program the solution that we're trying to get to. We should take that vibe coded solution and fix it by improving what we understand of the code and bringing the code and our mental model of it into closer alignment. And it happens that that is something that we can also apply generative AI tools to. Referring back to the preprint by Anthropic, they found that people who use the coding assistants in particular ways actually fared better on the cognition, the understanding of the task, than people who just got the tool to generate a solution and pasted that solution into their code. So we have a pattern language of interactive patterns for AI augmented software development. We can apply patterns that will help us understand vibe coded solutions. We can apply generate documentation, where we get the model to create a reading guide to the code it created so that we can understand how it's structured and how we might want to change it to bring it more into alignment with what we would like to do if we constructed this code ourselves. We can apply just ask, where we ask the model questions about the problem space and about how to do the solution, and then make changes to the code ourselves using those answers, but relying on our ability to write code based on our understanding. Incremental design repair for vibe code. Currently, I'm in favour of using generative AI to perform incremental design repair in terms of increasing our understanding and applying that understanding in the code we create. I'm not entirely sure that I would want to use generative AI for refactoring tasks. Refactoring is a very mechanistic process. You want to keep the behavior of the code the same while changing its design or changing features about its interfaces. And as such, the goals are well defined, the constraints are well defined, the transformations are generally mechanistic, and it's easy to apply traditional software techniques to quickly and reliably produce refactorings. Using generative AI in that circumstance can introduce deviations in behavior. It can introduce failures such as either test failures or undesirable behavior in untested code paths. And depending on whether you're using on-device models or not, it can cost a lot more than doing a mechanistic refactoring using a script or a text editor. But I'd love to hear what you think about that. How do you think about vibe coding as a deliberate debt choice? What do you think of the idea of refactoring using generative AI? Please, as ever, like this video, subscribe to the Patreon, get involved with the discussion. It'd be really interesting to hear from you, and I'll see you again soon.